Okay, so welcome to this video. We'll talk about esters, polyesters, and some environmental concerns when it comes to the usage of polyesters. We're also going to compare these with addition polymers that you find in alkenes. So what is an ester? An ester is a compound that contains that functional group, C-double-O. It's also called an ester link, or you can call it an ester bond. So these compounds have the following general properties. They have pleasant smells. They are said to be sweet smelling. They also are very volatile, and they're generally used in food industry as food flavoring and also as perfumes. So to make an ester, you require here a carboxylic acid and an alcohol. So let's look at a specific example. If you wanted to form ethanoate, which is an ester, you require ethanoic acid and ethanol. You also need an acid catalyst, which is usually sulfuric acid. So what happens is when the two react, your carboxylic acid is going to lose the OH group, whilst your alcohol is going to lose the H plus ion, and these two will combine to form water. So those two will combine, the H and the OH minus will combine to form water. This is why we call this a condensation reaction, because water is removed in the process. So we are going to have the carbon directly bonding to the oxygen when you remove the H and the OH. So this is what forms for us the ester link. So remember that you also form one molecule of water in this case. So when it comes to polyesters, you require these molecules to combine in large numbers. So instead, what you need here is a dicarboxylic acid, which is an acid that contains two carboxylic acid groups. So that's called a dicarboxylic acid. And you also require a diol, which is an alcohol that contains two OH groups. So what happens is these two need to combine, and when we are talking about polymerization here, we can represent the rest of the molecule with a rectangle, with those two rectangles. So we are concerned here with the far ends of the molecule where we have our functional groups. So you can simplify molecules this way. Okay, so what happens is that we have to form our ester link as before, where water is released and our carbon bonds directly to the oxygen. So we form our ester link, and now we have to allow this repeat unit that we have formed to combine with other repeat units. So we have to open the bonds. So we remove another water molecule in order to open those bonds so that this dimer can become a polymer. Okay, so when we open those bonds, we release another water molecule and we form that repeat unit. So we can have several of these repeat units combining to form our polyester. So this is what we have done here. We have combined a dicarboxylic acid with the diol to form a condensation polymer. So remember, we said, and we have released two water molecules as you saw. And remember, we said these molecules can combine in thousands, hundreds of thousands. So we need to put numbers to show how many of these molecules combine in a particular polymer. So we have to represent that number using an N. So we put N's on the dicarboxylic acid, an N. On the diol monomer, we put an N, and we put an N outside our bracket for the repeat unit. And we also have to put 2N for the water. Remember, we said we release water molecules firstly to form the ester link, and secondly to open those bonds. Okay, so this is how we represent condensation polymers in an equation. So it's important to note here that you require a dicarboxylic acid with that is an acid with 2 carboxylic acid groups, and a diol, which is an alcohol that contains 2 alcohol groups. Okay, so that would be a specific example. Ethanedioic acid can be combined with ethanediol to form polyethyl ethanoate and water. So you can represent that equation as shown. Okay, let's also look at some environmental concerns. So polyesters are better because they can be broken down by bacteria and some microorganisms, so they are biodegradable. If you compare these with addition polymers are non-biodegradable, so they will stay in the environment for a very long time, which is not desirable. So this is all for this video. Hopefully this will help you to understand polymers more. So I'll meet you in another video.